Hi, thanks for joining me. Today I'm going to be going over problem 1, week 1 from the summer Invariants maths competition. So for those of you that don't know, the Invariants is the Maths Society at the University of Oxford, and this summer they're running a competition where every week they're going to be releasing 3 different problems, and then the top 3 people at the end of summer who have answered the most correctly will win a prize. I believe they're Amazon vouchers. So anyway, I'll leave a link in the description below to the Facebook page of the Invariants where you can find out more details about the competition and how to enter and things like that. Anyway, this is week 1, problem 1, and over the next couple of days I'll be releasing solutions to problem 2 and problem 3 from week 1, and I'll be making video solutions to all the other problems as well, so come back if you get stuck on a problem so you can see the solution here. Anyway, this is a problem 1, and I haven't written it out in full because it is quite lengthy, but I'll leave a full description of the problem in the description below. Anyway, we have these 1,000 stones here, so stone 1, stone 2, stone 3, and so on all the way up to stone 1,000. And we have 2 players, Wenjie and Paul. Wenjie initially stands on stone 1 and then Paul diametrically opposite on stone 501, like so. Now they're each going to take it in turns to make moves through the stones, and then the winner is the player who lands on the other player. So if Wenjie makes a move and lands on Paul, then Wenjie will win, and if Paul makes a move and lands on Wenjie, then Paul will win. Anyway, Wenjie goes first, and here are the rules of how Wenjie can move. He can move either left or right, K moves, where K is some number between little m and big M. So Wenjie is free to choose the direction if he goes anti-clockwise or clockwise, and then he's free to choose the sort of distance he moves. It's an integer between little m and big M. Well, I haven't actually said what little m and big M are, but we'll come to that in just a second. So if little m was, say, 3 and big M was 10, then Wenjie could say, I want to move left 7. That would be perfectly fine. Then Wenjie has his go. Then it's Paul's turn, and Paul will have the exact same thing. They can move either, Paul is free to choose K between little m and big M and move either left or right. And then you win if you land on the other player, as I said. Okay, we also have that each player plays optimally, as is the case with most of these sorts of problems. And what we want to do is find all ordered pairs, little m, big M, such that it is possible for someone to win. Now, I guess one thing I should have said also is we have an inequality involving little m and big M. Clearly, little m is less than or equal to big M by this guy here. But we must have little m is at least 1 and big M is at most 1,000, like so. Okay, because obviously if big M was more than 1,000, then it kind of just, you could consider big M mod 1,000 or something like that. Anyway, we want to find all ordered pairs, little m, big M, such that it's possible for someone to win. And it's clearly it was hopefully quite clear that not all possible pairs of M and M will mean someone will win, because, for example, if you have M equals 1, then that means that Wenjie and Paul are always just going to move 1. That means they're forced to move 1 either left or right, and then hopefully you can see that because they're playing optimally, neither of them are going to lose, because if they put themselves in a position where they were going to lose, they can kind of run in the other direction, before that happens. Anyway, so I hope that all makes sense. And if you want to see the sort of the problem in full or read it again, I'll leave it in the description below. Okay, I've done a lot of talking, a lot of waffling, but if you want to have a go at the problem, pause the video now and give it a go for yourself. And I'm finally going to jump straight into a solution. Okay, so the first thing I want to do is make a quick observation about the game. And that is, if a player were to win, then they must win on their first move. And the reason for this is kind of intuitive by the fact that they're playing optimally. I'm not going to go through all the details, but I'll kind of give an example to illustrate it. Suppose there was a way for Paul to win on his third move. So not his first move, let's say his third move. And I'm going to show that this is contradictory, or Wenjie can prevent it by playing optimally. So let's go back in time to Paul's second move. So let's suppose Paul is about to take his second move, and let's say Paul is there. I don't know, Wenjie is there. Well, actually, let's not put there. That looks diametrically opposite. It doesn't really matter where they are. Now, so that Paul is about to take his second move. But now, if Paul could kill Wenjie, or sort of land on Wenjie's square, then Paul would do it there and then. But this is contradictory because we're supposing Paul wins on his third move and not his second move. So here Paul's about to do his second move. So because Paul doesn't win on his second move, then that means that Wenjie at the moment is in a safe distance from Paul. So whatever this sort of distance is here, Wenjie's safe from Paul. So Paul will do his move, and let's say he moves here. And now we're supposing that Paul will win on his third move. And what that means is that on Wenjie's move now, once Paul has done his move, his second move, Wenjie will have a turn. And that means that Wenjie will put themselves in an exposable position. So I don't know, let's say Wenjie moves here. And then that means that Paul on his third move would do that. But Wenjie can actually think about this and be smart and go, well, what I could do is just do the exact same move that Paul's done. So move that same distance in the same sort of direction. So Paul's moved, let's call that d units anti-clockwise. So Wenjie could also move d units anti-clockwise. And then what they notice is that it's Paul's third move, and Wenjie and Paul are essentially in the same positions, just rotating this circle kind of, as they were before Paul's second move. And because Paul couldn't kill Wenjie on Paul's second move, that means Paul can't kill Wenjie on Paul's third move. So I hope that's all made sense, but it's essentially down to the fact that Wenjie could cancel out Paul's move if Wenjie was in, sort of about to die, or if Wenjie did something stupid to put themselves in a position where they could get killed, or they could avoid that by just cancelling out Paul's move. So the only way the only way we can overcome this, the only way there could be a winner, is if Wenjie doesn't have a chance to do this. So right at the start of the game, well, the other player may not have had a chance to move. So the only time a player can win is if they win on their first move. Okay, so another quick observation I want to make is we can assume without loss of generality that little m is at most 500. So why is that true? Well, if little m was bigger than 500, then we can kind of form an identical problem with m less than 500. So if little m is bigger than 500, then certainly capital M is bigger than 500. Well, what does this mean, sort of going around the circle of stones? Well, let's suppose, consider Wenjie's first move. He starts there. Well, then, because he can move between little m and big M, either clockwise or anti-clockwise, so clockwise, he can move, say, in that region there. And if he were to move anti-clockwise, that corresponds to, say, that region there. But then, of course, this is identical to just saying, well, if we let little m prime now equal 1000 minus capital M, and capital M prime equal 1000 minus little m, because this situation here, because notice this distance here is 1000 minus capital M, which I claim is our new little m, or little m prime, and this distance here is 1000 minus little m, which is our new capital M prime. So these are kind of equivalent problems, so we can assume without loss of generality that m is less than or equal to 500, because clearly this m prime here is 1000 minus our capital M, and because capital M was bigger than 500, this guy here is less than 500. So without loss of generality, we'll assume little m is less than or equal to 500, but then to get the corresponding cases for when little m is bigger than 500, we kind of just do this translation, substitution thing here. Anyway, without loss of generality, little m is less than or equal to 500. Let's proceed. Okay, so let's go back to our first observation, in which we showed that if a player was going to win, they were going to win on their first move. So Wenjie goes first, so let's consider the case where Wenjie can win. Well, we said that Wenjie can only win, if Wenjie's going to win, they're going to win on their first move, so that means that Wenjie has to land directly on Paul's square. So Wenjie must move 500 either clockwise or anti-clockwise, and notice that it's equidistant either way they go, so that must mean that Wenjie must be allowed to move 500 goes. Now, because little m is less than or equal to 500, this is exactly the case. So Wenjie can win. Wenjie can win if and only if capital M is bigger than or equal to 500. Because if capital M is less than 500, well then Wenjie can't win on their first move, and then by our first observation, that means that Wenjie can't win. But of course, if m is at least 500, then that means that, if capital M is at least 500, then Wenjie can just move on their first move to Paul's square and win. So Wenjie can win if and only if capital M is at least 500. So that's kind of one of the cases of the little m, big M pairs. Now let's consider the case where Paul can win. Okay, so let's now consider the case where Paul wins. Now we just showed that Wenjie wins if and only if capital M is at least 500. So for Paul to win, a necessary condition is that capital M is less than 500. Now this isn't sufficient, as we'll see, because for example, Wenjie could move just one move across, and then if capital M was say 5, then Paul could only move 5 across, and so it wouldn't be able to catch Wenjie. So let's consider a circle. Wenjie starts here, and let's say Wenjie moves, K moves across to this point here. Oh, this is on their first go, by the way. So Wenjie moves, K moves across, and Paul is here, and then Paul is about to take his first move, and by our first observation, if Paul's going to win on his first move, so that means Paul must go this distance here, which is 500 minus K. So Paul must be able to move 500 minus K. And now you might ask, well, what about this guy here, 500 plus K? Well, then that's clearly bigger than 500, and that would contradict this guy here. So Paul must move this direction, and he must move 500 minus K, but we've also just got to check that that's eligible. So Paul wins if and only if 500 minus k is in our sort of valid range. So little m, big M, like so. However, Wenjie knows this, and obviously Wenjie doesn't want Paul to win, so Wenjie is going to choose k accordingly. So if Wenjie chose k, say, equal to 250, then Wenjie would move 250 to there, but then of course 250 is valid because, well, then Paul could just move 250 that direction and then land on Wenjie, and then Paul would win. Now, if, say, Wenjie moved just one across, so Wenjie just moved a little bit into that direction, one across, then the only way Paul could win is if capital M was 499, and then Paul could move 499 and move there. So it's clear to see there are some sort of limitations to what little m and big M can be, but if you just hopefully examine this in a bit more detail, you'll see that Paul can win if and only if little m plus big M equals 500. Now this is true because if little m plus big M was less than 500, then Wenjie could choose a k to just avoid Paul catching Wenjie in that first move, and similarly if little m plus big M was bigger than 500, Wenjie could also choose a k to avoid Paul catching Wenjie in Paul's first move. A little bit difficult to get your head around, but hopefully if you go through the details you'll see that yourself. But essentially Paul will win if and only if little m plus big M equals 500, because, well, it's firstly clear to see that if little m plus big M equals 500, then Paul can win, because Paul can just do 500 minus k, because if k is between little m and big M, then 500 minus k will certainly be between little m and big M, because little m plus big M equals 500. But if this wasn't true, then Wenjie could choose a k, so that Paul can't win in their first move, and hence none of them will win by our first observation. Whew, that is a mouthful. But yeah, that solves the problem. Obviously, you've got to go back and, we assume without loss generality that little m was less than or equal to 500, but by that sort of translation I had at the start, we have to consider the case where little m is bigger than 500, but that corresponds to cases where little m is less than or equal to 500. Anyway, I have done a lot of talking, and hopefully I've made a lot of sense, and hopefully the solution has made sense. But yeah, do check out the other video solutions to the other problems as well. For problem 2 and problem 3, I'll release them over the next couple of days. Anyway, thank you for watching. Thank you for your patience. I'll catch you in the next one. Have a great day.